Good day, viewers. Welcome to this class, and today we'll be looking at top JUPEB Physics past questions. The first question here says, the pressure of a confined fluid is measured reliably by which of the following devices? The pressure of a confined fluid. So you can see a confined fluid, meaning that you have your fluid inside a container that is what? In a closed system. And they're asking us, how do we measure it reliably so that we have what? Accurate measurement of the pressure. Option A says we use the manometer and the mercury barometer. Option B says we use a thermometer and a mercury barometer. Option C says we use a hydrometer and a manometer. Option D says we use a barometer and a spectrometer. Now, the correct answer to this question is using a manometer and a mercury barometer. And why do we do that? The manometer is used for measuring the pressure in closed system, while the mercury barometer is used for measuring the atmospheric pressure. So the correct answer to that question is option A. So that takes us to question number 2. We say the equation A is equal to 2 plus 2t represent the acceleration of a particle in time t. So this represents the acceleration of a particle in time t. The question is, find the instantaneous velocity after a time of 4 seconds. So they've given us the equation for acceleration, but we are asked to find what? Instantaneous velocity. And the only way we can find the instantaneous velocity is to what? To integrate our acceleration, because whenever you integrate acceleration, you're going to get what? Velocity. And when you differentiate velocity, you are going to get acceleration. So if we integrate our acceleration, the integral of acceleration is supposed to give me the integral of 2 plus the integral of 2t plus c. So this is the same thing as saying that I have my velocity, because when I integrate acceleration, I'm going to have velocity. Velocity is equals to, if I integrate this will give me 2t, because this will become what? There's a t raised to power 0 here. So this will become what? 2t raised to power 0 plus 1 over 0 plus 1. Then plus, this will become 2t raised to power 1 plus 1 over 1 plus 1. And that is plus c. So this means that my velocity here is going to give me 2t plus, this will become 2t squared over 2. So, plus c. So, at the end of the day, I'll be having v is equals to 2t plus t squared plus c. So, this is what I have. So, what we have to do now is impute our value for time here into this formula for velocity to get our instantaneous velocity. And that would mean that my velocity, therefore, it means that velocity, therefore, would be equal to 2 open brackets 4 plus 4 squared plus c. So this will give me 8 plus 16 plus c. And that will give me 24 plus c. And we assume that in this equation that our initial velocity is 0. And if initial velocity is 0, automatically it means that my constant c is 0. So this will become what? 24 meters per second. So the correct answer to this question is 24 meters per second, which is option C. That is question number 3, which says, which of the following statement is correct about an elastic collision? Option A says, only the total momentum of the colliding object is conserved. Option B says, only the total kinetic energy is conserved. Option C says, both of the momentum and total kinetic energy are conserved. Option D says, neither momentum of the colliding bodies nor the total energy is conserved. In an elastic collision, both momentum and kinetic energy are conserved. So the correct answer to this question is option C, because both momentum and kinetic energy are conserved. So that takes us to question number 4, which says, a string with a force of 80 Newton has an extension. So we have a force of 80 Newton, has an extension x at 0.05 meters. If it is used to shoot a stone of mass, so we have a mass of 20 grams, what is the velocity of the stone? We don't know the velocity of the stone. Now, for us to solve this question, we know that the energy stored in the string, which is the elastic energy, is equals to the kinetic energy. This means that my half Fx is equal to half mv squared. So this is same as saying that my Fx is equals to mv squared. So with this, we can find the velocity of the stone. So this is 20 divided by 1000, which will give me 2/100 kilogram. So the force here is 80, so I have 80 times the extension is 0.05. This is equal to the mass is 2/100 times v squared. So this is the same thing as saying that I have 2v squared is equals to 80 times 5/100 times 100 when I cross multiply here. So this 100 will cancel out this 100. So it means that I have v squared is equals to 80 times 5 divided by 2. And that would mean that I have that my v squared is equal to 40 times 5. And that would mean that my v squared is equals to 200. So I'll find the square root. It means that my v is equals to square root of 200, which is the same thing as saying that my v is equals to square root of 100 times square root of 2. And that would mean that my v is equals to 10√2 meter per second. So looking at this, that's the same thing as saying that my v, if you put it in decimals, because if you look at our options here, our options are in decimals. So if you put it in decimals, this is the same thing as saying my v is 14.14 meter per second. So looking at this, it means that my v at the end of the day is 14.14 meter per second, which is option D. This is question number 5, which says the reluctance of an object to start moving when at rest or stationary, and its reluctance to stop once it starts moving is known as dash. Now, the reluctance of an object to start moving when it's at rest or to stop moving when it is in motion is according to Newton's first law of motion, which states that an object will continue in a state of rest or uniform motion unless an external force acts on it. So, and that law is called the law of inertia. So, the correct answer to this question is inertia, which is what? Option A. So that is also question number 6, which says two blocks of masses M1. So I have M1 to be 300 grams, and I have M2 to be 500 grams. In contact with each other, rest on a table. The coefficient of friction between each block and the table is, so our mu was given as 0.4. What must be the value of the applied force if the blocks are to have an acceleration? We have our acceleration as 200 centimeter per second square. So, and they gave us G in the question as 9.8 meter per second square. So in the question, what they're asking us to find is our net force that must be what? Applied. So we don't know the net force. And we know that our net force that must be applied when a body is in motion is the force of friction plus the force of motion. So in this case, what I have is mu mg plus ma. So all I have to do is what? First add our masses together. So my total mass here is going to give me 800 grams, which is equivalent to saying I have what? 8/10 kilogram. So I will use this to calculate my net force. So my net force, therefore, is going to give me 0.4, which is a mu, times my mass, which is 8/10, times my G in the question was given as 9.8. This is plus. The mass is still 8/10, times my acceleration is unknown. Oh, acceleration was given in the question as 200 centimeter per second square, which is the same as saying I have 2 meter per second square. When you divide by 100, you convert it from centi. So this is times 2. So this means that I have 0.4 times 0.8 times 9.8 will give me 3.136 plus 0.8 times 2 will give me 1.6 plus 3.136. So that will give me 4.736 Newton. So it means that my net force is what? 4.74 Newton, which is option C. When you approximate this 6 here, you have what? 74, which is what? Option C, 4.74 Newton. That is also the next question. That's question number 7. It says, the magnitude of the mass of an object placed at the Earth's north pole is dash. Option A says it is 0. Option B says it is greater at the pole than on Earth's surface. Option C says it is lesser at the pole. Option D says is of constant value. Please note that the mass of an object is always constant irrespective of the location, which is why the mass of a body will remain the same wherever it is placed. So the correct answer is what? Option D is of constant value. So that takes us to the next question. That's question number 8, which says vector A and B are said to be parallel if dash. Now, vector A and B are said to be parallel when the product of their diagonals are 0. So what does that mean? It means if I have vector A times vector B to be equal to 0, then the two vectors are said to be parallel. So the correct answer to this question is option A, which says what? A dot B equals to 0. So that takes us to question number 9, which says which of the following is or are correct? Roman figure 1 says all fundamental quantities are scalar quantities. Roman figure 2 says all derived quantities are scalar quantities. Roman figure 3 says all fundamental quantities are vector quantities. And Roman figure 4 says not all derived quantities are vector quantities. Please note that all fundamental quantities are normally scalar quantities, unless, of course, you decide to do a derivative of it. For example, the fundamental quantity length has a derivative called displacement. So ordinarily, length is a scalar quantity, which is a fundamental quantity, unless you are not putting it in terms of its derivative, which is also a fundamental quantity in its own right. But ordinarily, length on its own is a scalar quantity. But if you put it in terms of displacement, it becomes a vector quantity. So all fundamental quantities in their original form are scalar quantities. So which means that what? Option Roman figure 1 is correct. Then also, not all derived quantities are vector quantities. There are derived quantities that are not vector quantity, like speed. Speed is a derived quantity, but it's not what? A vector quantity, which also makes Roman figure 4 correct. Roman figure 2 and Roman figure 3 are completely wrong because all derived quantities are not scalar quantities and all fundamental quantities are not vector quantities. So the correct options are Roman figure 1 and Roman figure 2. So we're looking for our Roman figure 1 and Roman figure 4 in our option, and that is what? Option D, which is what? Roman figure I and Roman figure IV as the correct answer. So that takes us to question number 10, which says a body is dropped from rest and allowed to fall free from a given height under gravity. The kinetic energy at its halfway is dash. Now, at halfway, because as the body is falling, there is an increasing velocity. As the velocity continues to increase, velocity is increasing as it is falling. So at halfway, our KE is greater than our PE. So at halfway, KE is greater than PE, which means that our kinetic energy is a little above its initial energy, because its initial energy is what? PE, as it is falling from rest. And our KE at half level, since our V is constantly increasing, our KE would have what? Be higher than what? Our PE, which means that what? The kinetic energy is a little above half of its initial energy, which is what? Option A. So that is also question number 11, which says an aircraft of mass, So we have the mass of the aircraft as 2 times 10 raised to power 4 kilogram. Lands on an aircraft carrier deck with a horizontal velocity. So we have velocity as 90 meters per second. If it is brought to rest, in a distance, so we have a distance S as 100 meters. Calculate the average retarding force. So we are looking for the retarding force. We do not know. But we know that the work done here is equal to what? Force times distance. And we know that also that since this is a body that is what? Moving, it is having what? Kinetic energy. And we know that kinetic energy is also equals to what? Work done. So if my work done is equals to force times distance, and my kinetic energy is also equals to work done, this means that force times distance is equals to kinetic energy. And that means that my force times distance is equals to half mv squared. So we're going to use this formula to find out what our force is. So this means that my force times 100 is equals to 1 over 2 times 2 times 10 raised to power 4 times my velocity here was given at what? 90. So I have what? 90 squared. So this will mean that I have force 100 force is equals to, these two cancel out these two. So I have 1 times 10 raised to power 4 times 90 squared. So I have 8100. This means I have 100 force is equals to, so I have 81,000,000. So I have 81 million. So I divide both sides by 100 divided by 100. This means that the force here, that will give me 81,000,000. So that will give me 810 Newton, which is the same as saying I have 810 kilonewton, or you can say 8.1 times 10 raised to power 5 Newton as the force. So our correct answer here, and okay, the question they said what? Retarding force, which is what? A negative force. Hence we have what? Negative here. Retarding force. So the correct answer to this question is minus 8.1 times 10 raised to power 5 Newton. So that is question number 12, which is the safety speed of a vehicle on a curved horizontal road is that. So we're trying to get the formula for the safety speed of what? A vehicle on a curved horizontal road. Now, for a vehicle to continue moving on a curved horizontal road without skidding, what you're going to do is what? Equates your frictional force to your centripetal force. So, and we know that our frictional force is mu mg, and our centripetal force is mv squared over r. So this is the same thing as saying that if I cross multiply here, I'll be having r mu rmg is equals to mv squared. So m will cancel out m. It means that my v squared is equals to mu rg. So I'll take the square root of both sides, which means that my v is equals to square root of mu rg. So the correct formula for calculating the safety speed of a vehicle on a curved horizontal road is square root of mu rg, which is what? Option B. Moving on to the next question, it says a small metal sphere with diameter, so we're given the diameter as 12 millimeters, which means that my radius is 6 millimeters. And if you convert that, that is 6 over 1000, which will give me 0.006 meters. Is dropped into glycerin. The viscous force on the object is 3, so we have our force as 3.2 Newton. To calculate the coefficient of viscosity, so we are looking for coefficient of viscosity is unknown. Given that the terminal velocity Terminal velocity is 8 meters per second. And we know that our force under viscosity is 6 pi nRV. This is the same thing as saying that my N is equals to force over 6 pi RV, which means that my N, which is my coefficient of viscosity here, is equal to, my force was given as 3.2 divided by 6 pi times, my radius here is 0.006 times, the velocity was given as 8. So this means that what I have is equal to 3.2 divided by, so I have 6 pi times 0.006 times 8. So this will give me 0.905. So I have 3.2 divided by, and that will give me 3.54. So it means our answer is 3.54 Newton seconds per meter square. Per meter square. So we are looking for 3.54. So looking at our option here, our correct answer will be option C, which is what? 3.54 Newton seconds per meter square. That's option C. Moving on to question number 14, it says, butter paper is an example of dash. Now, what they are simply asking you in this question is, what happens when you add butter to paper? So when you add butter to paper, the paper becomes translucent. You discover that what? The paper is oily. And the reason why it is oily is because of the butter that you added. And when the paper is oily, you can no longer see through the paper, but light can pass through it. Little amount of light can pass through it. So in translucent object, little amount of light can pass through it, but one cannot see through it. So the paper becomes what? Translucent. So butter paper is an example of translucent object, which is what? Option B. So that is to question number 15. We say, determine the rate of radiant emission per meter square from a black body at 25 degrees Celsius. So in this question, we have that we are looking for the rate per meter square, which is what? Power over area. We do not know. And in the question, they gave us the temperature as 25 degrees Celsius, which is equivalent to saying 25 plus 273, and that will give me 298 Kelvin. Moving on from there, now we are asked to what? Find this, and the only way we can do this is when we use what? Stefan Boltzmann's formula, which says that power is equal to Stefan's constant times area times temperature raised to power 4. So this is the same as saying that my power over area is equal to Stefan's constant times temperature raised to power 4, which means that my power over area will be equal to Stefan's constant, which is 5.67 times 10 raised to power minus 8 times my temperature here, which is 298 raised to power 4. So when you multiply these two together, you are going to get 447.14 watts per meter square. Why is it watt per meter square? Because we have what? Power over area, which is what? Rate per meter square. So our correct answer to this question is option B, which is what? 447. So that is also the next question, which is question number 16. It says, in the longitudinal waves, the direction of vibration in medium of particle is that. The direction of vibration in medium of particle is that. The direction of vibration in medium of particle in a longitudinal wave is parallel to the direction of the wave propagation. What does this mean? It means that both the particles and the wave travel in the same direction. So they are moving in the same direction. So the correct answer is what? Parallel to the propagation of the wave, which is what? Option B. Moving on. Question number 17 says, a body emits 60 cycles per second. So what I've given to us there is the frequency of this wave. That's what? 60 hertz. 60 cycles per second, which is what? 60 hertz. Of a progressive wave traveling at So they gave us the velocity also as 20 meters per second. Then they said, what is the wavelength of the wave? So we're looking for lambda. We don't know. So we know that the velocity of a wave is equal to f lambda, which means that my lambda is equal to velocity over frequency, which means that the wavelength lambda is equal to 20 divided by 60. So this will cancel this, and I'll have 2 divided by 6, and that will give me 0.3333 meters. So the correct answer to this question is 0.33 meters, which is option B. Okay, that is the question number 18, which says calculate the critical angle of a ray of light which is incident at a water glass surface. Now we have the refractive index of water in the question as 1.33, and we have the refractive index of glass as 1.5. So we are asked to find what critical angle, and we know that what sine of the critical angle is equal to the refractive index of water over the refractive index of glass. So that means that my sine of my critical angle is equal to 1.33 over 1.5. So 1.33 divided by 1.5. So it means that my sine of my critical angle will be equal to 1.33 divided by 1.5. So my sine of my critical angle will be equal to 0.8867. So it means that my critical angle is sine inverse or arc sine of 0.8867. And that means that my critical angle is 62.45, which is approximately 62.5 degrees. So we're looking for 62.5, which is approximately 63, since they have approximated to whole number. So the correct answer to this question is 63 degrees, which is option D. That takes us to question number 19, which says, if two objects are each in thermal equilibrium with a third object, then the two objects are in thermal equilibrium with each other. This is a statement of that. Now, this statement is based on Zeroth law of thermodynamics, where it said that if A is equal to B and B is equal to C, in equilibrium, this means that my A is equal to C. This is what Zeroth law of thermodynamics. So the correct answer to this question is option B, which is what Zeroth law of thermodynamics. So that is the next question, which says the sum of a bed with an intensity of 1.4 times 10 raised to the power minus 5. Please, it's supposed to be a minus 5 here. So that's typographical error. So the intensity was given as 1.4 times 10 raised to the power minus 5 watts per meter squared. And frequency, they give us the frequency as 6 kilohertz. That's what? 6,000 hertz. Is held by a hunter in the woods. Calculate the displacement. So we're looking for the displacement. We don't know. Displacement amplitude of the sound. Then they gave us our density rho as 1.2 kilogram per meter cube. They gave us the velocity of sound in air as 343 meter per second. And we know that our displacement is equal to the square root of 2 intensity over rho v omega squared. So here we do not know the angular velocity of this particular sound. So the first thing we're going to do is to what? Know that our angular velocity is equal to 2 pi f. Angular frequency, is equal to 2 pi f. So in place of our angular frequency, we're going to put what? 2 pi f, which means that our displacement will be equal to square root of twice the intensity over rho v 2 pi f squared. So all we are going to do now is input our values into this formula and calculate our distance or displacement amplitude of the wave. So our displacement amplitude of the wave will be equal to square root of 2 times 1.4 times 10 raised to the power minus 5 divided by, so I have rho, which is 1.2 times, my speed is 343 times, I have 2 pi times 6,000 or square. So this means that my displacement x will be equals to square root of, so this will give me 2.8 times 10 raised to the power minus 5 divided by, so this will give me 1.2 times 343, that will give me 411.6 times, so I'll have 2 pi times 6,000, so that will give me, so I have what, 12,000 pi, or let me put it in decimals, so that will give me 37699.11 square. So this is the same as in my x is equals to square root of 2.8 times 10 raised to the power minus 5 over, here I will have, so I will square this and multiply it by 411.6, so that will give me 5.8485 times 10 raised to the power 11. So it means that my x is equals to, so I have 2.8 so this is what I should have. So at the end of the day, I divide this by 5.85 divide by 5.85, so this will give me square root of 4.79 times 10 raised to the power minus 17. At the end of the day, it means my x will be equal to 6.92 times 10 raised to the power minus 9 meters. So looking at our options, we realize that the option is not there, and that is due to the typographical error that is there, because the normal intensity of the stand of bed for it to be heard has to be times 10 raised to the power minus 5. Hence, we're using times 10 raised to the power minus 5. We don't know the original intensity that was given in this question. So if we're using times 10 raised to the power minus 5 due to the typographical error, this is the answer that we're going to be having. We come to the end of today's class. Thank you for staying with us to this moment. Don't forget to share with your friends, and see you in the next class.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 type of different exams, including JAMB, WAEC, Cacao, NEET, IALT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.